The fundamental theorem of calculus. Now, this is a theorem that has more than one part, and we're only actually going to look at one part of that theorem here. Part of the fundamental theorem of calculus states that if we have a curve like so, between A and B, and the curve is y equals f of x, then the area that's shaded blue here, which is trapped between the curve, the x-axis, and the lines x equals a and x equals b, is given by the integral from a to b of f of x dx. That's equal to big F of b, take a big F of a, note that a and b are what's known as the limits here, where big F is the antiderivative of the function little f, and we looked at antiderivatives just recently. Definite integrals have the following properties. So we have the integral from a to a of f of x dx being equal to 0. And that's fairly obvious. We're looking at an area that's got a width of 0. The integral from b to a of f of x is the negative of the integral from a to b of f of x. Now, if you think about what we just wrote down, that's also fairly obvious, because we said the integral from a to b was f of b, take away f of a. So this one's going to be the other way around. It's going to be f of a, take away f of b. It's going to be the negative. This one here just says that if we have a constant multiplying the function, like a number, just 2 or something, we can slide it outside. It has to be a number, though. It can't be something to do with x. This one here says that if we integrate between a and b, f of x, and then between b and c, so a to b, b to c, that's equal to the integral all the way from a to c. That last one's not difficult to think about either. So what we're saying is that this integral plus this integral is equal to the whole thing. Now there's just one more. If we integrate the sum or difference of two functions, that's the same as the integrals, the sum of the integrals or the difference of the integrals of the two individual functions. Now this one, again, is quite important. They're all important to some extent, and really you'll get used to them by using them.